Hi everyone! Welcome to today's deep dive. We're tackling a fascinating piece of C23 code. It's a vector macro implementation designed to provide a dynamic array abstraction. We'll review its design, its use of new C23 features, and discuss potential improvements. Get ready to explore modern C programming. Our first impression of such a macro is often its elegance and the promise of type-generic containers. The C23 standard brings powerful tools to the table, and a vector macro is a perfect candidate to leverage them. Let's start by examining how the macro likely achieves type generality. A key C23 feature here is typeof_unqual. This new keyword is a game changer for generic programming in C. It allows the macro to obtain the unqualified type of an expression, meaning we can define a vector that truly works with any data type without resorting to void pointers and manual casting. This makes the code significantly cleaner, safer, and much more readable. Imagine vector_push_back, my_int_vector, 42, or vector_push_back, my_struct_vector, some_struct_instance. The type information is automatically handled. This is a massive improvement over older C idioms. Next, we consider __va_opt__. This C23 feature is incredibly useful for variadic macros, especially when dealing with optional arguments. For instance, if our vector macro supports an initial capacity or a custom memory allocator, __va_opt__ allows us to omit a comma if no optional arguments are provided. This cleans up macro invocations, making them less prone to syntax errors and more user-friendly. It ensures that vector_init, my_vec, and vector_init, my_vec, 100, both parse correctly without needing separate macro definitions. Now, let's talk about safety and robustness. A common macro pitfall is multiple evaluation of arguments. Does the macro evaluate its input expressions more than once? This can lead to unexpected side effects or performance issues if the argument is not a simple variable. A well-designed macro uses temporary variables to store argument values, preventing this problem. Memory management is another critical area. How does the macro handle malloc and reloc failures? Does it return an error code, assert, or perhaps set an error flag? Robust code always considers these edge cases. A good implementation should check the return values from memory allocation functions and provide a clear, consistent way to handle out-of-memory situations, possibly by returning null or a specific error indicator. The reallocation strategy is also important. When the vector grows, how does it expand its capacity? Doubling the capacity is a common and efficient strategy, minimizing the number of reallocations. Is this growth factor configurable? This impacts performance for different use cases. Proper initialization and cleanup are also essential. Vector_init and vector_free macros or functions must be provided to prevent memory leaks and undefined behavior, ensuring resources are acquired and released correctly. Readability and maintainability are paramount, even for macros. Is the macro easy to understand and use? Are the names clear and intuitive? Macros can sometimes be challenging to debug due to their textual substitution nature. Good documentation, clear naming conventions, and minimizing macro complexity are vital. While C23 features like typeof_unqual help simplify the internal logic, the overall interface needs careful management. The macro should ideally encapsulate the internal data structure, such as data, size, and capacity fields, providing an abstract interface so users don't need to interact with these implementation details directly. Finally, we consider performance. Are there any hidden performance costs? For example, unnecessary data copies or inefficient loop constructs within the macros expansion. A well-designed vector macro should strive to be as close to raw array performance as possible. While there might be minor overheads due to checks or specific C23 feature usage, these should be negligible for typical operations. The goal is to provide convenience without sacrificing execution speed. So, that was our look at a C23 vector macro implementation. It's exciting to see how new C features empower us to write safer, more generic, and more expressive code. We've seen how typeof_unqual and _va_opt__ simplify complex tasks, making dynamic arrays much easier to manage in C. We also discussed crucial aspects like error handling, performance, and overall design considerations that lead to robust code. Thank you for joining me on this code review journey. If you found this discussion helpful, please give it a thumbs up to support the channel. Don't forget to subscribe for more deep dives into programming topics and modern C development. Your support helps me create more content like this. See you next time.